Hello, everyone. It was loud. Thank you for coming to our talk. My name is Anastasia. I'm a software engineer in the Jetpack Compose text team in Google.
Hi, everyone. I'm Alejandra, lead under engineer at HubSpot.
Today, we're going to tell you about the evolution of TextField APIs in Jetpack Compose. So we'll start with recapping the existing old TextField APIs. We will then explore the shortcomings of those APIs. Then we will tell you about the new shiny TextField APIs. And in the end, we will discuss a little bit what it means for you as developers and what is the readiness of these APIs. OK, so let's start from the past, and let's recap the existing TextField APIs. You probably all know that Compose is not a single library. It's a suite of libraries. And we're interested in material and foundation layer here. So on material layer, we have TextField and outline TextField. Those are APIs that, on top of basic functionality of the input fields, they also implement material design theming. On foundation layer, we have basic TextField. Now, you will be reaching to basic TextField whenever you want to implement your own design system in the application. All of the things that we're going to mention today are true for both material and foundation layer. And in our code samples, we will use basic TextField so that you know. OK, so let's recap the basic TextField APIs. So basic TextField is a composable function, and it takes two main parameters, a value. This is a string that we are going to display in our text field, and also on value change callback, which is triggered whenever there is an event like users typing something through the keyboard, and you should be updating your state, your text string, inside this on value change callback. There is another override that takes text field value. On top of the string text, there is two other parameters, which are selection, which also holds the information about the cursor position. And there is a composition, which is IME, input method editor composition, not to be confused with Compose runtime composition. So IME composition is used by keyboard to, for example, predict a word. OK, so the shape of the API that we just saw pretend that its text field is a stateless component. However, it is not true, and basic text field is stateful. There are multiple places where the state is held. The IME holds the state. Again, as I mentioned already, it helps predicting the word that is coming, or it's used when multiple steps are needed to construct a word or a glyph. There is a state holder. This is you as an API caller, you will hold a state. And there is a state in the text field itself. It acts as a synchronizer between the keyboard or IME state and a state holder. OK, so you might be wondering, so what's the problem with the fact that text field, basic text field, pretend that it's a stateless component when it's actually stateful? One of the problems is that synchronizing different states is actually difficult, and there are multiple edge cases that we need to take care about. Here's just an example how we support the string-based text field. So internally, we keep everything inside the text field value, but because text field value also has selection and composition, we need to make sure that we, for example, only fire on value change callback when the string changes and not those ranges of composition and selection. So this might seem like a very easy problem, like what the issue is making it work with a string. However, it's surprisingly quite a complicated problem. And you don't need to read this code or understand it. I just wanted to show you that we need to actually keep a few copies of text field value, and they are different kind of copies, and we have a lot of explanation inside our implementation so that we actually handle a lot of edge cases, and then there are multiple places where actually we need to synchronize this. OK, so this gets out of sync, can get out of sync pretty easily. Another problem is that if on top of that you add asynchrony, well, then the text field is doomed. So here's an example, how would you do it? And actually, there was a talk earlier today from Manuel who explained you how you do state management. And this is a recommended way, but if you do this for basic text field, well, this is a problem here. So you have a view model where you keep your text field value as a asynchronous observable stream, for example, state flow. Then inside onValueChange callback, you make a asynchronous call, which is often you make a verification, you make a backend call, you make a verification, and only then you update the text field state. So does it look familiar to anyone? I'm sure a lot of you use it this way. And this is what you get as a result. So there is a difference between what we actually type in and we actually see on the screen. So if you don't see what's going on in the video, we are entering around 14 characters digits from 1 to 6. But as you can see, we only see a few, some of them replaced, deleted, etc. So it's like non-deterministic behavior here. So I won't go into much detail what's going on here, but basically multiple source of truth lead to the fact that TextField gets out of sync pretty quickly and it cannot easily recover from this. So what we did over the past, I think, like a year or so, we suggested you use snapshot state instead to hold your TextField state, and also you update the TextField as soon as possible without introducing any delays. And we've covered this a lot, like all of the details in multiple talks and articles. So if you want to check them out. OK, so this was the state management problem. There is another problem, which is visual transformation API. So if you ever wanted to implement a specialized text field, for example, for entering a credit card number or a phone number, you would use that API. So the API was called visual transformation. It was a functional interface with a filter function that took the original string, original text, and transformed it into to another text, the one that is formatted text. And importantly, in this API, you had to provide an offset mapping, the mapping between the original string and the transformed string. And this, actually, let's look at an example first. So imagine you wanted to implement a text field that takes verification code. So it takes 6 digits, and they are grouped into triplets, and there is a space in between. And if you haven't entered a digit yet, we will put the dot. OK, so how would you do that? First, we implement the we define an object that implements visual transformation API. Sorry, yeah, let's go here. And then the most important thing is that we need to provide mapping between the original text and transformed text and vice versa. And the important part to understand here is that in the index in the original text might map to different or multiple indices in the transformed text and potentially vice versa. So this is a many-to-many mapping. And providing a correct mapping was actually a very hard task. And API doesn't prevent you from providing incorrect mapping. So if you did so, your user probably would get a crash, and you would get an exception. And, well, you can take a look at an exception. It's not very helpful. You didn't know how to recover, how to make your offset mapping correct. So what we were trying to do is we introduced what is called validating offset mapping. So essentially, every time we called one of those transformed from original to transformed text or from transformed to original, we call in a validate method that would help us to provide you with a more meaningful error message if there was an issue with the offset mapping. So we did it. However, this approach is very reactive, and it didn't actually help you to prevent crashes in the first place. So developers were complaining. You found a lot of bugs. So take a look at this bug alone. It gets more than 100 upvotes. So it was really a problem. So at this point, team realized that we need to think about new API, and we started thinking about redesign. And when thinking about it, we decided to take this holistically and to take a look whether there are other parts that would benefit from new API. And there are a few. One of them, for example, is a filtering. So if you needed to do a filtering, so for example, to only take a digit or something like that, because you would do this in onValueChange, but because we only have text, old text and new text, you would need to do that diff in yourself to actually understand like what's going on. It's like insertion, replacement, etc. So it wasn't cool. Another unfortunate API is that we have the single line max line problem. So like you could set single line to true, but still set min lines and max line to whatever, like 5. So it was like, okay, so what's going on here? So single line would win in this case, but you would need to read the documentation to understand that, and well, it wasn't ideal. So we could definitely do better, and we actually did. And now over to Alejandra to talk about the new Shiny API that the team developed.
Okay, so now on to the new APIs. So what is available right now? And by right now, we mean that almost everything is available in latest Compose 1.6 alpha version. So you can like try them out right now immediately after this talk if you want. So let's say we're implementing a sign-up screen. We have 2 fields, a username and a password. Before, quick recap again, in basic text field 1, the state is defining composition. We remember saveable, so it survives process state. And then the text field receives the state and a callback, which you use to update the value. So what changes now is how you define your state. We now have a function called remember text field state. Remember text field state that will create and remember a text field state instance of a class. It receives an initial text, which is what you show when you first initiate it. In our case, it's empty, and for your convenience, and also an initial selection, which is also empty. And this pattern is familiar to us, right? Because for other components, we have lazy column that defines its state with something called remember lazily its state. So this shape is like very familiar to us, hopefully. And then what also changes is that we no longer have a callback. Or value change goes away. We can no longer do that. And we just simply define our new shiny new basic text field 2. We pass in the state. That's it. We got the text field working. That is really all it takes. Now, every time there is update coming from an event, for a typing event, the basic text field internally knows about it and synchronizes the state. Everything works great. Think about how a lazy layout updates the scroll state without having you to do anything, right? This will work in the same fashion. So for general state management, if you need to hold your state in the view model to apply certain business rules to it, you can totally do so. You just define your state like this, username, text field state, again, empty as an initial state. And in composition, you can just declare your text field, basic text field 2, and pass in the state from the view model.username, and this also works. So that's how you would do it. Very quickly on styling, as Anastasia was mentioning, we don't have yet the material wrappers ready, but you can use all the components that you're familiar with already. For example, the text style block to change things like font size and font color and line height, all these things. You can also use all the modifier system, right, to do things like border, which is what we're doing there in the sample. We define a border, like very simple as well. And obviously all the other modifiers that you need. And you have access to a decoration box as well, if you want to mimic something like outline text field would do, to get more control of the draw space for your text field. You can also do that if you need to. You probably want also your username to be a single line. And we just said that currently maybe it's like very confusing because what is the result of merging all of these configurations? Like single line you can understand, but maybe merge with min lines and man lines is confusing what this outputs. Well, basic text field 2 eliminates this ambiguity. To configure single line, you use a parameter called line limits, single line, that's it. This is all it takes, right? Like there is no there is no questioning. So single line, what it does is the text field as you type is always a single line tall. It ignores new lines completely, even if you type them, and it scrolls horizontally when the text overflows. And this is in contrast with multi-line that receives min and max lines that you want your text to be. The text starts being min height in lines tall, and then you can type in, and it can grow to be max heights in lines tall. You can keep typing, and yeah, it overflows. You go to the next line, and as you type, you get horizontal scroll for your text field. If instead of lines, you know what the min and your max height is expressed in terms of DPs, we already kind of have API for that, we can use modifier height in. You just define your min and max values configured in DP. And then that's it. Your text field will stay between those values. You get also scroll vertically to move in your text field. Great. So now on to some meaty stuff. Let's talk about observing state, right? So our text field works. It's hoisted to the view model, and now what we want to do is apply some business rules to it, and maybe observe this state, and with that, update the UI. So we can hoist the state to the view model, that's fine, and we define a new username has error value of type stateflow. And this will be true or false depending on whether we execute some asynchronous call to see if you can use that username or not, right? And the way to observe the state, our new text field state, is by declaring snapshot flow, an API that hopefully most of you are familiar here if you're using Compose. And then as you observe it, you can do something. And this shape is so common, right, that actually basic text field 2 offers an extension function that is called text.flow that does exactly that. It's a wrapper of snapshot state of a snapshot flow of the text field state. So now we're observing our state just fine, and we can call maybe map latest, execute our asynchronous validation to it, and then that it runs for every new character that is types. We can even use debounds for flow, which will give us a buffer of time between each character type, so you don't execute multiple times the same API call. You give a breather to the user so it finishes typing, and you don't have to, overuse your API calls. A little bit of a efficiency thing there. And final step, stating, you convert this to an observable state flow. That's it. From Compose, you are going to observe this state flow as you're used to do, and maybe show an error if it is true or hide it if it is false, like we're doing right now. Another convenient alternative to perform asynchronous operations on each character typed is, again, text as flow call, and then collect latest, which will allow you to execute a call routine or an asynchronous call, and just call, whatever it is that you need to do there. And this is also super common to do. So we have another extension function for that, and that is called for each text value. That gives you a suspend function scope for you to do all your synchronous calls. So we take the example that we saw before. We can rewrite it using this API instead. We define a suspend function, validate username. Inside, we do the text field state dot for each text value. We execute our asynchronous request. And all of this happens in the view model, right? And then from Compose, what you do is just you create a launch defect to observe the typing changes, the typing events that are being observed in the view model. And then you have the same thing as before, right? Like you're observing the username has error snapshot state to show a new component in Compose or not, a new error message or not. So that is also what you can do to observe state. And okay, one more way to observe your state. We're going to go back a little bit. This is basic text field 1. I know they are very similar. So remember that we said that basic text field 1 has this API shape for defining state. We receive a value and a callback, and it's not great because in the callback, you can do something asynchronous, and then because there are multiple copies of state, you might break the text field state, producing the errors that Anastasia was describing. So thankfully now we have a new API shape, and that shouldn't happen anymore, right? Well, the truth is that that might not be totally accurate, because the truth is that basic text field 2 provides you the same API shape. Why? Because we like it, it's convenient, developers are used to it, it just works for simple cases. So now you're wondering, okay, so then how is this an improvement, right? Like how are we preventing the issues that we said before? How are we not going to be able to introduce asynchronous delays here and break the whole thing? And the answer to that is that the magic to prevent that happens under the hood. There is a new private modifier. You don't need to know this, but just fun facts. New modifier under the hood called state syncing modifier. And that will be sure to synchronize the state that is stored with the one coming from the callback. But there's more to it. So whatever happens inside the lambda on value change will be always called. So you can go to town and like do all your synchronous calls that you want to, because that will always be called. But there is something that is not going to be called while the text field is in focus, and that is assigning the state like that. So when the text field won't update the state with your programmatic changes while the basic text field is in focus. After you lose the focus, say you focus on something else, all those changes will be applied. This might look like, this might result in you typing and you're not typing and doing changes programmatically in the callback, and you don't see that reflected. Why? Because the single source of truth now will be your typing events. And this internal mechanism guarantees that there is only, that the editing process is preserved throughout the whole process, because it keeps only one source of truth. It basically ignores what you do programmatically. So I guess what we are saying is that the recommendation is use this API shape because it's familiar, because it's simple, for simple cases, but for more complex cases, please piggyback on the other more convenient way to define your text field state to avoid this unpredictable behavior that maybe you do not expect. Right, so we talked a lot about defining state and observing it and doing something with it. But okay, why if you need to programmatically alter the edit session on each character typed and modify the state programmatically? And there is a multitude of cases in which you need to do that. Like most likely you're doing this right now. For example, the most simplest one of them all is clearing the whole context of the text field. And to do this and access this edit session, we have a new class called TextField Buffer. This class holds information about the state, like the length and the current selection, if there is any. And it also gives you a bunch of very useful methods to alter it, like, for example, replacing the text and appending something at the end, inserting new characters, deleting characters, like the majority of the things that you need to do. And it will also give you methods to alter the selection as well and repositioning the cursor. So, for instance, let's implement our button to delete the contents of our text field. We have our state defined in the view model just like before. We have a method clear field. We do .edit, and then when we do when we call the method .edit, you're in TextField buffer land, and we can use all of the methods that we said before. For example, delete, you delete the whole thing, and reposition the cursor. And this is so common that as well, it has a extension function that does this for you. Super easy, just call TextField state clear text, and it does it for you. Another example, if your username is an email, maybe you can have some buttons to append the email provider there, for example, at gmail.com. You would define your state and your basic text field, and maybe in a button, you would call and on click your state.edit again, and then call append certain text. Very simple, very straightforward. And last but not least, what if our validation fails? You want to select the text just so the user can type a new one very easily. What you would do here is like you're already observing the state. You're observing the state. What you want to do is identify if you had an error, and if you do, you call a method highlight. And what highlight does is, again, do a state.edit.select all, and it's just as simple as that. And you can use a bunch of other methods that you need as well.
Thank you. Okay, good. Okay, so now that we talked about how to observe the text field state and also how to make changes programmatically, let's come back to the visual transformation problem. So imagine that we need a specialized text field for entering a phone number or a verification code. So here's a picture I like to draw in my mind when thinking about this problem. So we have a user typing on a keyboard. We apply a filter function, or broadly speaking, an input transformation function before preserving the state or whatever user typed in the text field state. And then we are going to display this back to the user. And before doing so, we may apply another function, output transformation, that allows us to do some additional formatting on top of the text without actually changing that tag that is preserved inside that text field state. So coming back to the verification code example, here how it maps to the picture that I just drew. So user types AB, then we capitalize this input, implying changes to the text field state. So the text field state will now be capital A, capital B. And then when displaying this to the user, the text field applies output transformation and pads missing characters with dots and adds space in between. And this is what will display. So now that if you read the text field state.text, it will show capital A, capital B. Okay, so now let's talk about this first part, the input transformation. You may hear us referring to it as filtering as well. Okay, so input transformation is a functional interface or SAM interface. The method is called transform input. It takes the original value and it also the value with the changes in the form of text field buffer, so you can do pretty much whatever you like with the text field buffer, and Alejandra already showed you multiple methods to change your value. And know that unlike the old way, where to the filtering, where inside on value change callback, you will do the full diffing to understand the changes, the text field buffer APIs actually provides you with a list of changes. So it gives you a text range in the updated text field buffer, and the range that was replaced in the original text. Okay, so it was transform input method of the input transformation interface. Now, additionally to that, we also have a keyboard option field. The idea here that when you filtering your input, you should also be thinking about setting the keyboard type to a certain type. So for example, if the UI asks user to type a number, then you should be setting your keyboard to numeric or decimal, for example. Therefore, we expose these keyboard options here in the input transformation API interface for your convenience. Okay, so let's see how to use this API. Here's the text field that we want to implement. It's take the verification code. It accepts digits only. And here's the implementation. We first define an object called digits only transformation that implements input transformation interface. We implement our transform input method. So in our specific example, we check the changes from the text field buffer, and if those changes contains digits only, we're happy and we proceed with the changes. But if there are non-digit characters, then we revert the changes. So look how simple it is, right? So you don't need to do any different to understand whether it's like an insertion or replacement, etc. So everything is done for you internally. Okay, I've mentioned already that it's great to provide keyboard options, and we do so. We pass the numeric keyboard in the same object. Now that you might be tempted in general to do filtering with setting the keyboard only, like if the UI is expecting digits only, then you would set your keyboard to numeric. In general case, it wouldn't work. So for example, if you use a hardware keyboard, then, well, it doesn't work, right? So the correct approach here is to provide both the input transformation, but also set the correct corresponding keyboard type whenever it's possible. Okay, so the last step here is to pass the object that we just defined to the basic text field. Now, because input transformation is a functional interface, you could simply pass a lambda directly to the composable function where you do your filtering. This works nicely if you only have a single text field like that needs this specific input transformation. However, if there are two or more text fields like this, then it makes sense to actually define an object like we did before. And of course, don't forget to pass the correct keyboard type to the composable directly here. Now that this keyboard option passed through this composable function will override the one passed through the input transformation interface. So something to keep in mind. Okay, so now let's look at another example again, verification code. And in this case, we accept 6 uppercase letters. Again, we can do it similar we did before, manually, everything. However, what's even better is that we have some built-in filters or input transformations. And this example can be built completely out of those. So first, to limit the number of characters that the user can type, you use max length integers API where you provide the number that the input should be limited to. For the uppercase letters, we have a input transformation called all caps. You must pass a locale there. This locale will be used for the capitalization mapping. And now, oh yeah, you also need to, you also should pass the capitalization parameter to the keyboard options. So in this case, all of the letters on your software keyboard will be capitalized. Okay, putting this all together, let's implement the whole example all together. And you might notice already that we can chain input transformation using then function. So these filters or input transformation are applied sequentially. So in the given input transformation, you see the changes that were applied by the input transformation that in the chain before the one that we are currently in. Okay, so we've covered the input transformation. In our example, with the verification code, that would be limiting the number of characters to 6 and also accepting either digit only or capital letters. Now let's move on to the output transformation. So in the verification code example that we used all over, we've implemented, additionally to what we've implemented with the input transformation already, we want to do two things. We want to replace all of the missing characters, or like not yet typed characters, with the dots, and we want to group them into triplets and add a space in between. So there is an API for that, for like formatting. It's called output transformation. Similar to the input transformation, this is a functional interface. Know that unlike input transformation, where we make changes directly to the TextField state that will be preserved, with the output transformation, we don't actually update the internal TextField state. Instead, you can think of it as if we were applying this transform output function every time we display the text to the user. Okay, so let's implement an example that we've saw a few times already, but with this output transformation API. Again, at the input, similar with the input transformation, we define an object. This object implement the output transformation interface, and we implement the method transform output. Inside this method, we do two things. First, we call the append on the buffer to insert dots to all of those missing characters. And then on the TextField buffer, we also called insert to put the space on the in between the characters. Okay, so this is pretty much it. So you see, you don't need to provide the offset mapping anymore. So like no mappings between the original transform text. This is all done implicitly for you by the API. And previously, that mapping was actually a source of crashes and confusion. Okay, so this is output transformation. Note, however, that this API is still under construction, and as of today, it's not merged yet. So it's subject to change, but I would like you to try this out and give us feedback. For simple use cases, however, there is a one-to-one mapping, meaning that a character in the original map maps to the exact same maps to the character with the exact same index in the transform map, and vice versa. We already have an API in the basic TextField 2. I won't be mentioning this exact API here because, well, it's subject to change. It probably will be gone when output transformation is merged. But I wanted to mention it existed because this is the one that is used to mask characters in password or secure text fields. And so far, one of the main usages for the visual, like old visual transformation API in the TextField version 1 was actually creating password or secure text fields. And there are means for that in basic TextField 2 already. However, the password text field is such a special use case of the basic text field that in version 2 of basic text field APIs, we actually decided to go with a completely new, separate composable function for that. And now over to Alejandra to tell you more about this.
So we're building the password field now. What do we used to do before? Quick recap. We would define a regular basic text field, and the important part was the visual transformation. We would define a password visual transformation, and that was it. Anastasia has already hinted it out, but the first step that we have now is, you guessed correctly, we'll define the state just like we did before, and then we will have their shiny new component, composable, basic secure text field built on top of basic text field 2. As its own standalone composable that with configurations that we're gonna see next. Most notably, the thing that it provides as an API is text obfuscation mode, which defines how the text looks as you type. And the default behavior is reveal last type, in which you briefly see the last character until you type the next one or it times out. Additionally, or in contrast, you could define hidden, in which you never see the character, or maybe visible, in which you always see the character. And why is this helpful? To implement something like a button to temporarily tweak how if you see the password or not. So it would be very simple to implement. You define a snapshot state variable is hidden, and then your text obfuscation mode will be conditioned to this property. It's either reveal last typed or visible, and then maybe a button to toggle this configuration. And that was it. Super simple. Having basic secure text field separately gave the team and developers a lot of things out of the box. For example, the team, it allows for them to optimize for security under the hood, preventing things like making the content of this text field not be persisted in memory more than it should, avoiding things like memory spoofing. We also get defined UI for free, like these char masking and text obfuscation modes, and then defined behaviors. For example, the text toolbar modifications. Very quickly on that one, a basic text field 2, when you select part of the code, part of your state, you get your toolbar to allow you things like copy, paste, code, select, and this is the text toolbar that you get, but in basic secure text field, you do not have copy and cut for security reasons. And if you're interested in how you access the composition local for local text toolbar, you can read the code, super simple to understand. Okay, so what else do we have for the new API? A bunch of things, but we were resuming into 3. Text field scroll state, right? So now we have access to modify the scroll state programmatically. You define scroll state like you would with any other composable component that you have, like lazy column, for example. And then you pass it into the basic text field 2 in the scroll state parameter there. And then you can define a slider, and as the value of the slider, access that scroll state and modify it. So that will make implementing something like this very simple, right? In which you can scroll a different component, and because your scroll state is hoisted, you can modify the one that you have in your text field, which is kind of pretty cool and very not as trivial to do in the current API shape that we had today before this. What else do we have? The team worked very hard to make all the gesture support, including magnifier and double taps to select word, a personal favorite. And we have something like, called undo state as well. And very quickly on this one, when we defined our state with text field state API, we get access to a class called undo state that allows you to do a lot of cool things out of the box, like know if you can undo or redo edit operations, and then methods to undo or redo, and maybe clear the history of all those operations. So let's say that we have a couple of buttons below our basic text field, and on click, you access your text field state, and you call undo, and maybe in another button you call clear history, which would make implementing something like this very simple in a couple of few lines of code. You do a bunch of edit text operations, you can undo, redo, clear the history, there is no history there. You cannot even begin to think how to implement this in the current API shape. So it's great that we have all of this for free. Okay, so where do we go from here as developers? We covered basic text field 2, how to style it, how to do state management, observing state, how to edit it programmatically, input and output transformations, and our new ways to define a password text field, and a lot of other things that will make our lives better and simpler as developers, like accessing the scroll state and undo state. What we expect, you can try it out right now. This is available in Compose 1.6, as we said. It's under construction. It's in a separate package called text2, so it's clearly identified. The plan is that it's not going to be called basic TextField 2 or be in this package once everything is stabilized. So try it out. Just remember, it's not production ready yet. And after you try it out, the best thing that you can do is give the team feedback. Think about all of these complex editing use cases that you're using in your app, and think if they accommodate the current API, because there ain't no better time to communicate this than right now, because the team is working on this right now. You can give feedback through Google's issue tracker there and create a feature request or a bug. You can also join the Kotlin Lang community there and keep in touch through Slack and send a message through the Compose channels. So let's discuss there. You can also reach out to the team directly. Zach and Halil there are main engineers working on this project right now. We also have Anastasia here on the text team in Compose as well. Next up, merging, as Anastasia was saying, merging output transformation changes so you can test it out. Multi-style text editing obviously is a very, very highly requested feature, and the team will make sure that this is worked on next. And of course, material wrappers, so we don't have to style everything manually. So that is it from us. Thank you so much for listening. Hope you're all excited as we are, and enjoy the rest of the record.